I just drank some water. Now, eventually, because I drank this water, I'm gonna have to go to the washroom a little later. But how does that happen? How does this water eventually turn into pee? I mean, this is not yellow right away. Something must have happened to it. Did the water just go into my stomach and just get mixed with yellow dye and then just come out like that? Not really. That's not what's happening. It's much more complicated than that. See, you ever hear the fact that your body is made of 70% water? Kind of a weird fact to think about because, I mean, look at yourself. I don't think any of us are, liquid beings. We're all pretty solid. Um, but what part of your body is mostly liquid? If you guess blood, well, you're completely right. Your blood is where all this water goes. Your blood transport all of that water throughout your body, and then your body uses that water for various purposes, and then brings it back to heart, and then keeps going back and forth. That's cool and all, right? But then how does the water in the blood, or even how does the blood turn into pee? That happens in the kidneys. And I think you've heard of the kidneys before. It's two of them actually, the two little organs pretty much in your back over here. And they are sort of like a distillery, a moonshine distillery, taking your blood and turning it into pee.
Cool.
Welcome, children. This is the kidneys. Kidneys are kind of like this red, pinkish thing. And that's where I am right now. I don't know how I'm going to get out, but I'm going to get out somehow. But while I'm here, let me show you how we turn lovely, lovely blood into not so lovely pee. Okay? Now there's a process. Where it starts from is, remember a couple minutes ago I was just talking about blood. It starts in your heart. Blood is pumping out of your heart into the rest of your body, everywhere. Imagine rivers of blood, which is what your arteries and veins are. Maybe that's not the best thought ever, but just imagine rivers of blood for now, okay? Now some rivers of blood are going to your head, your legs, your pinky toe, and everywhere else. But there is a renal artery, right? This is the name of a particular vessel that's going to your kidneys, okay? So the blood goes through into your kidney via the renal artery, and then it goes into the millions of nephrons in your kidneys. Now nephrons, I like to think of them sort of as like sponges. Okay, they're reabsorbing some of the stuff in the blood that you're gonna need, elsewhere in your body. But it's not gonna take in everything. There's some stuff that you're just gonna have to pee out because you just really don't need it. Okay. So where this process starts is something called the glomerulus and the Bowman's capsule. The glomerulus, I like to think of it as sort of a filter, right? It's filtering out a lot of nutrients out of your blood. There's a lot of stuff in your blood, including blood cells. And blood cells, you do not want to pee out blood cells. If there's blood in your pee, that is really, really bad, okay? And that may hint that your glomerulus is not working, among other things, okay? So we're filtering out, what's not needed. And you'll find that there's actually quite a bit that filters out. So you're gonna, some of those chunks, they're kind of getting stuck. That's your blood cells, okay? See that? Little chunks of stuff. It's your blood cells just getting stuck in there. You don't need that. I mean, you do need that, but you don't need to pee that. Okay? So this is glomerulus and then the Bowman's capsule. Just some funny names for parts of the nephron, okay? Which is within your kidney, as I mentioned. Next, where all this filtrate is gonna go into your proximal tubule. Your proximal tubule, if you come a little bit closer, is a place where all this filtrate you've just taken out you're gonna absorb like a sponge, as I mentioned, any stuff you need, like sodium chloride, which is salt, potassium, which is in bananas, ammonia, bicarbonate, water. Water. I love water, and your body loves it too. So it needs to take that out because you don't want to pee all that. You want to keep that in your body. It'd be pretty bad if you were peeing, important nutrients. So it's going to reabsorb all that in the proximal tubule. Then it's going to move on to the descending loop of Henle. Okay? So all this is going to go in the descending loop of Henle. And this is where more water will be taken out. Now, normally about 85% of the water is going to be taken out unless a certain hormone called ADH from your brain, which is a messenger, basically it's like a chemical, is gonna run to your kidneys and say, crap, we need more water, okay? It probably means you're dehydrated, so ADH will tell your kidneys, we need more water, so it'll actually reabsorb almost 100% of the water in the descending loop of Henle. You see how it's going down? And it's gonna go into a loop, into the ascending loop of Henle, and it's gonna take out salt. Okay? And that's going upwards this time. It's going to take out salt. And one cool fact to note is that water likes to follow salt. So it'll actually come out through a process called osmosis, and it's like there's going to be this pressure created, and it's going to take water out. So basically, kidneys don't have to do any work, actually. The water is just taken out because it just likes to follow salt. Sort of like a clingy friend if you have one of those. Okay. Next, we're going to go down into the distal tubules. Kind of distant from the other tubules, a little farther to the right or left or wherever position it's in. This is where more nutrients are taken out, and stuff that you still need is still be like the entire time it's like a sponge. It's taking stuff out the entire time. This is always happening. And then you're gonna get into the collecting duct. So now it's kind of turning into like urine, kind of pee-like, and this is like the last ditch effort to like take anything else out. Okay, because now at this point this is gonna go down into your bladder, and it's gonna be peed out in the washroom. So now we've turned our lovely blood into pee. Lovely pee. Well, not so lovely pee. And this is a very important process because whatever's in the pee is stuff that your body didn't need, like deadly toxins that can kill you over time. So this is some very important stuff when you really want this process to be happening at an optimal efficiency. So before I leave, I want to leave you with two little facts, some information that you might want to know. First one is, ever eat almost meat for every one of your meals? Like in the morning you eat some eggs, for lunch you have chicken, and then for dinner you have a nice steak. Well, that might not be the greatest idea, because when you have so much meat has something called protein, and protein is a really important molecule that you have to build muscle. But if you eat too much protein, then you're just gonna pee protein out, and you're basically like wasting your money. You might as well have less protein and have something that's like more in carbs, or something that's more has more fat or something like that. That way you're not wasting money. And the final thing I want to let you know is drinking water is very, very important. Multiple studies have shown that drinking 6 to 8 cups of water per day, which is more than what we usually drink, unfortunately, is very beneficial for you. It'll increase the efficiency of your kidneys, and it'll prevent certain chronic diseases that you just, obviously, you don't want them. So if you're drinking less water than you should, talk to your doctor and get the recommendation how much more water you should be drinking per day, and you'll be a-okay. That was the function of the kidneys and how blood turns into pee. I hope you enjoyed it, and drink more water.